Hi there, my name is Susan Copeland and I'm one of the curriculum specialists for elementary math for CMS. I create the content for 5th grade. Today we're going to be unpacking Unit 2, Fractions as Quotients and Fraction Multiplication. Before we begin though, I'm going to tell you just a tiny bit about myself. That's me in 5th grade. As I was growing up, math was always a strong point for me. The thing is, I didn't really love math. It was okay, and I seemed to be able to do it, but I really liked science because science made sense to me and it was hands-on. It was just a lot of fun, but math was like, meh. I didn't really love math, but I did decide when I went to ASU to make math my concentration. But very quickly, I decided that the math courses in college were too hard, and maybe I had just reached the point of all of the math that I could do. I graduated from Appalachian in 1995 and went out to teach. Here is my first 5th grade class, and here's my first 5th grade class in CMS. I taught for 11 years, just like I learned, and then I moved to a facilitator position. And I was in the math facilitator position for 11 years. During that time, I had the opportunity to learn from the elementary math specialist at the time, and it rocked my world in mathematics because I learned that math could make sense and math is fun. In fact, I was so excited about math, I went back to UNC Charlotte and earned a middle school math certificate where I had to take all kinds of math classes that had that math class that I thought was too hard as a prerequisite. And this time I understood the math and I enjoyed it. I'm really excited about this new curriculum that we have because it's designed to help students know mathematics deeply, to use and apply mathematics, and my personal favorite, to enjoy mathematics. And these are the things that I felt like were missing from my math experience prior to moving to CMS. Okay, just a quick finish up on my timeline. I'm at 8 years of being a math specialist, and if you do the math on that, 10 and a half, 11, and 8 puts me at almost 30 years. So this year, I will be at year 30. But you know I'm a mathematician, so I've got this pattern going. I was a classroom teacher for about 11 years, 11 if you count student teaching. I was a math facilitator for 11 years, and so I think I may just be a math specialist for 11 years. We'll see how that goes. Okay, so let's get started. Here's our agenda for today. We will work through these sections today. On each title page, you will see the parts of the agenda through which we are working. Underneath the title, you'll see tasks that we will address in that section. Let's start by accessing some important documents. First, you will need to log into My NC Ed Cloud and access Math Rocks. The enroll code is on the screen if you haven't enrolled yet. Once you're in Math Rocks, select 5th grade. On the 5th grade page, you can access the year at a glance using the right top button. Then select Unit 2. Everything is in a folder except the curriculum guide. I will refer to the curriculum guide throughout the deep dive, so you may want to have it open. You will also need to access the note catcher using the bit.ly on the screen if you haven't already opened it. Pause if you need to access these resources. Our first section is the unit overview. That aligns with tasks 0 and 1 on your note catcher. We always want to begin a new unit by looking at the North Carolina Standard Course of Study aligned to the unit. The standards are located on slide 4 in the curriculum guide. Unit 2 includes NC 5 NF3 and NF4, and also we're continuing work with NC 5 OA2 on expressions. Click on the Post-it note on slide 3 of the curriculum guide. You can access the North Carolina Unpacking document for 5th grade on this slide or on the home page for 5th grade math. Take a moment to read and annotate or take notes about these standards using the Unpacking document. Pause the video and restart when you're ready. I'm going to share a few things I noticed and would want to take note of before teaching this unit. You might have some other things that you noticed. That's the great thing about working with a team. We all notice different things. And if we share what we're thinking about, it gives everyone a stronger picture of the goals of the work we will do in Unit 2. I noticed that very specific denominators are mentioned: halves, thirds, fourths, fifths, sixths, eighths, tenths, and twelfths. I noticed one-step word problems are included. It's important for students to understand that a division expression can be rewritten as a fraction, with the total represented by the numerator and the divisor represented by the denominator. Students have experience with area, length, and set models. And I noticed that students have experiences with fractions less than 1, equal to whole numbers, and mixed numbers. Let's look at NC5 and F4 now. There were several important things that I noticed. The work in 5th grade builds on the work in 4th grade, where students multiply a fraction less than 1 by a whole and consider 2/3 as 2 times 1/3, for example. In this unit, students multiply a fraction by a whole number or a mixed number by a whole number. Just as in 4th grade, this may involve problems with halves, thirds, fourths, fifths, sixths, eighths, tenths, and twelfths. Even though we see it here in the unpacking, students will not be multiplying a fraction by fraction until Unit 3. Students should create and use visual fraction models, including area models, diagrams, and number lines. Notice that North Carolina clarifies here that develop the algorithm does not mean that the end game for 5th graders is the algorithm for multiplying fractions. Students should always use models in 5th grade and may begin to explain the algorithm using models. You are currently working with NC50A2 in Unit 1. In Unit 1, students mostly used expressions to represent volume and area situations. Students will continue to represent area situations in this unit. However, some of the side lengths will be fractions. Students may also encounter order of operation situations that include fractions within this unit. The fraction denominators will be the same as other items in this unit. Let's move to Task 1 on your note catcher. This is located at the beginning of lesson notes in the curriculum guide on slides 9 and 10, and it's also in your note catcher in case you would like to annotate as you read. When you finish, try to summarize the gist of the unit in one sentence. Then discuss with your team how the unit follows the design elements of invitation, deep study, and consolidation. Pause the video to complete this task. For this unit, students are first introduced to the concept of interpreting a fraction as a quotient. Then students learn a fraction can represent either a division situation or a fraction of a group. Finally, in the last section, students interpret the product of a whole number and a fraction in terms of the side lengths of a rectangle. Student understanding uses context involving equal sharing to relate division and multiplication. Later, students think about area using rectangles and context such as gardens. Now let's think more specifically about how the standards and targets build across the sections of the unit. This unit is separated into 3 sections. Read the section overviews on the first 3 slides of the deck linked in your note catcher. Those slides are also located as slides 12 through 14 in the curriculum guide. Then look at the 8 task cards taken from the unit on slides 5 through 12. Slide each task to be below the section within which it falls. Talk in your PLC about how you decided which section each task belongs within. How does each task support the goals of the section? Pause the video now and return after completing the sort. Here are the sections with the lined cards. Cards A and H focus on equal sharing, which is found in section A. Cards B, E, and F address the relationship between multiplication and division and connect models by addressing how they are related to both multiplication and division expressions. Cards C, D, and G involve finding the area of rectangles in which one side length is a fraction or mixed number. Students write or connect the expressions to the models. Now, let's take a moment to unpack some of the learning goals by doing some tasks. Read the learning goals for each section and complete the aligned activity in your note catcher. Discuss the guiding questions with a partner. Think about what representations are used in these activities and how do they support students in understanding the learning goal for the section. And what strategies might students use when they do the work on these activities? How are these strategies related to the section level learning goals? Pause the video to complete task 3 now and continue when you're ready. Again, I'm going to share a few thoughts I had, but take them with the thoughts that your team had as you worked. These are not the right answer, it's just some things I thought about. The Section A task allows students to explore which situations result in less than 1, equal to 1, or more than 1 pound of blueberries. Students might use the diagrams to test situations that result in each. They experience dividing a whole number by a whole number, resulting in a fraction or a mixed number. Then the Section B tasks challenges students to make connections between models and expressions. It allows students to see that the same model can be represented with different expressions. And finally, the Section C task uses the area model to help students see the distributive property at work with mixed numbers. Students might mistakenly believe that the area is the same for both situations before they represent it. Representing helps students to see why the two expressions are not equal. Now we're ready for backwards planning. You will complete tasks 4, 5, and 6 on your note catcher in this section. Assessment resources are located on slide 6 of the curriculum guide. You can access the assessment by clicking on the assessment thumbnail. The reassessment is linked just below the assessment. If you haven't already taken the assessment, take a moment to complete the items. Consider with which sections each task is aligned and record the section on your note catcher. As you work, consider what misconceptions and challenges you can anticipate. When you finish, share your thoughts with your PLC. This is a great time to learn from the experience of your team. Pause the video and complete task 4. Push play when you're ready to continue. Okay, so here is where I landed, but you may be able to make some arguments for how some of these would fit in other sections, but this is what I was thinking as I went through. Notice that the open response question, it depends on the approach that students take. It could have elements of A, B, and or C in it. Let's also take a moment to think about how Unit 2 fits in coherently within and across grade levels. Take a moment to review this 3rd grade task, that's task 5, looking back, and consider how the 3rd grade work supports learning in Unit 2. Pause the video and continue when you are ready. In 3rd grade, students find the area of rectangles with whole number side lengths. Students also build understanding of area as the number of square units needed to cover a rectangle. Now let's think about how this unit will support students looking forward. Take a moment to review this 5th grade Unit 3 task and consider how the work of Unit 2 supports learning in Unit 3. Pause the video and continue when you are ready. In Unit 3, students will find the area of rectangles for which both dimensions are fractions. Students will need to connect area to multiply expressions when both side lengths are fractions, and students will need to partition both side lengths of a rectangle to find the area. Now, let's take a moment to do a little bit of math together. Let's do these activities that are in Task 7 on your note catcher. You can try these items on your own first. Push pause, and then you can continue when you are ready. Okay, let's look at the first problem about Lynn and Han first. They ran a 3-mile race. I'm just going to use a tape diagram. It just looks like a long piece of tape. It's just like fraction strips. And I'm going to partition it into 3 equal parts, or as close to that as I can get, because I'm showing each of the 3 miles, 1, 2, 3. It's a little bit like a number line, but a number line would be different because a number line we would mark with 0, 1, 2, and 3. And this tells us that they each ran the same distance. So that means I need to partition it into 2 equal parts. Some students may do that in a way that just cuts it down the middle here and say that Lynn did this part that is orange and Han this part that is green. And then we can see that each one of them ran 1 whole and 1/2. Another way that students might solve the same problem, we could start with our tape diagram again and separate it into the 3 miles, but this time instead of dividing the whole thing in half, I could separate each mile into half. I'm just going to draw like this, this, and this. And I can imagine that Lynn ran the first half of each mile, and Han ran the second half of each mile. In this first example, when I was looking at Lynn, I saw Lynn had a whole mile and a half a mile, which was 1.5. In this one, it's 1/2, 1/2, and 1/2, which would be 3 halves, and since it takes 2 halves to make a whole, that is also equal to 1.5. Students might answer that as 3 halves, or they might answer it as 1 1/2. Okay, let's look at the second activity. In the second activity, students have to find the area of each of these shaded regions. Notice the first one is building off of what students learned in 3rd grade. They can see that this side is, this printout didn't turn out good, but this side is 6. So students could multiply 1 times 6, but they can also see that there's 1, 2, 3, 4, 5, 6 holes to find the area. So they could use counting strategies, or they could say 1 times 6. On this one, they can see that the width of the shaded portion is 1/2 and the length is 6. So how much is that? It might feel overwhelming to students. I don't know how to figure this out if a side is a fraction, but if they use this model, it's actually very easy to figure out. So I know I could move this half here, and so that makes 1 whole right there. So I've used that one. I can move this half here, so that would make another hole there, and that one's gone. And then I can move this half here, and that would make another hole right there. So that would be equal to 3 holes. Students might also say there's 1, 2, 3, 4, 5, 6 halves. So they may have said there's 6 halves, and then they reason 2 halves make a whole. So the first 2 is a whole, that's just what we did there. The second 2 is another whole, and the next 2 are another whole. So they would still get 3 even if they started with 6 halves. But just knowing that that means that's a half, a half, a half, a half, a half, and a half. Okay. Well, just like they did that here, now when they multiply in C, the width is 1/3 and the length is 6, so what they have is 1/3 times 6. But what is that? They can figure that out by thinking of this as 1/3, another 1/3, another 1/3, another 1/3, another 1/3, and another 1/3. So now there are 6/3, and with 6/3 I could take 2 of these and move this one here, move this one there, move this one here, and move that one there, and now I have 2 holes. So 6/3 is equal to 2 holes. And then in the last one, we can see the width is 1/4 and the length is 6. So now this is still 1/4 times 6, and we have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. What students might see in the pattern is that they have
6 holes here. That's like 6 over 1. And then 6 halves when it's a half, 6 thirds when the width was 1/3, and now they have 6 fourths when it was 1/4. So students may mention that and that pattern, and then they could use that. You might say, well, what if the width had been 1/8? What would you end up with? 6/8. And students can say they know that there's 1, 2, 3, 4 makes a hole, and then there's 2 fourths left, so that would be equal to 1 2/4, which we also know is 1 1/2. Okay, so students were drawing their own partitioning in the first one. In the second activity, they're figuring out the area. Let's take a look at the third one now. Okay, so in this one, it starts off and tells them to find the area of the shaded region in square units. Wow, there's a lot on this one, so it's a lot to think about. Let's just start off by trying to find the area of it. So if I look across here, I can see that there's 1 hole, 2 holes, 3 holes, 4 holes, and then 2/3. So if I think about the holes, that's 4. And then there's 2/3. Oops, my sloppy 3. There's 2/3 right there. So that's 4 2/3. I'm going to put a plus sign right there. And then I could also think of that as, since there's 4 holes that are all partitioned into thirds, I might even think of that side as 12, 13, 14 thirds. Okay? And then if I come to this side, I can see there's 1, 2, 3, 4 holes on this side. So in this section, if I just want to count the holes first, there's 4 by 4. So that is 16 holes, just like when I was in 3rd grade. I can figure that out, that there's 16 holes. But here, now these are thirds. So I have 1, 2, 3, 4, 5, 6, 7, 8 thirds. So that part would be equal to 8 thirds. I could also think about that. That's 2 2/3. I should write that, shouldn't I? If I have 16 here and I have 2 2/3 there, I can now add those together. 16 plus 2 2/3 is going to be equal to 18 2/3. So the area, and I just kind of explained it as I went, was 18 2/3. And I might even want to write the expression up here too. 4 times 4 2/3 is equal to 18 2/3. Okay, now I'm going to come down here, and it tells me to select all of the expressions which represent the area of the shaded region. I just figured this one out because that was 4 and then 4 2/3. So I know this one does in fact represent this. But now I'm looking at this next one at 16 times 8/3. I'm not really sure where that's coming from because I see there's 16 holes right here, and I see there's 8/3 right here. But this means 16 groups of 8/3. So are there 16 groups of 8/3? I see an 8/3 there, 1. So there could be 1 if I went straight down, 2, 3, 4, 5, 6, 7. No, there's only 7 groups of 8/3. But I did over here add 16 plus 8/3 to get 18 2/3. This one does not work. Now I'm going to look at the next one. Now this one says 14 thirds times 4. 14 thirds times 4. I did think about 14 thirds earlier, didn't I? And I had 14 thirds across here. So that's 14 thirds. That's 2 groups of 14 thirds, 3 groups of 14 thirds, and 4 groups of 14 thirds across here. That one works. Now 56 thirds. Whew, that's a lot of thirds. So let me see if I can figure that out. If it's how many thirds, because that's just that there's not any operation, no multiplication there. So I just need to see, are there really 56 thirds in this whole thing? If I think about this, there are in a column, let's do a column at a time. So there's 3, 6, 9, 12. So that one has 12, that one has 12, that one has 12, that one has 12, and we figured out that one just had 8 earlier, remember? So if I say 1, 2, 3, 4 groups of 12 thirds, that would be 48 thirds. I'm just going to write the word, 48 thirds, and then I have 8 more thirds right there, plus 8 thirds. I could write it like this too. It doesn't matter. Okay, and that would be 56 thirds. So wow, yes, that is a possibility there, or that is a way to express what we see here. And then on the last one, this says 4 groups of 5 thirds. Well, we just realized it was 4 groups of 14 thirds. So when I look across here, if I were thinking just 5 thirds, that would just be like 1, 2, 3, 4, 5. That would only be 1, 2, 3, 4. It would only be that part. So this one does not work. Okay, and that's our answer. And this would be really tough if we hadn't done the work that we had already done in this unit, but I can reason about each of these parts. You can see I've scribbled all over it, but I can reason about each of these expressions using the image itself. And the work with identifying a hole first and counting holes builds off of the work in 3rd grade. Students had to partition, even in that beginning task, they were having to partition. When they were dividing a whole number by a whole number, they were having to partition, just like we did on our first problem. I don't know where I put it already. Oh, here it is. Okay. So students had to partition on here, so they were thinking about counting halves and counting wholes and halves together. That helped to build toward this. And then when students worked on this problem, or on this type of a task, they were having to think about adding like units there. Just like we added all of those thirds in this final one, in this one we added halves together, we added thirds together, and we added fourths together. All right, that was a lot of fun. Thanks for doing a little bit of math with me. I hope you enjoyed that too. Let's wrap up our time today with some key points and next steps. You can build student understanding in this unit by using sharing situations to support students in understanding the relationship between division and fractions. And students should use tape diagrams and models to multiply a fraction by a whole number or a mixed number by a whole number in this unit. So what are next steps? If you haven't taken the assessment in full yet, that's a great start. As you plan for daily lessons, refer to lesson notes on slides 16 through 23 in the curriculum guide. While there is not a ton of information, there is information that will be important for you to know before you implement the lessons. For example, you can see that there is a note about a small group task that was adapted in Lesson 5 in the teacher notes because the denominators were not aligned to the North Carolina Standard Course of Study. Another thing to look for is CMS added lessons. Lesson 6 is not in the student workbook. This is a lesson focused on multiplication as repeated addition. The following lessons address multiplication of a fraction times a whole number, which we think of as fraction of a set. But what is important to know here is that you will need to print the student lesson. Notice the student lesson is linked in the resources. And this will impact all lessons that come later in the unit too. For example, Lesson 7 is a lesson in Open Up workbooks. but rather than being lesson 7, it's lesson 6 in the workbook. You will see that here in the curriculum guide and also in the lesson plan. This helps you get students to the correct lesson in the book. So the curriculum guide lesson notes are a useful tool to make sure that you know standards alignment, added CMS lessons, and which pages to use in the workbook. Thank you.